want to make a video on the great biologist. He's actually a mathematical biologist, Ronald Fisher. I'm trying to give a summary of it. Fisher is a very big name in biology. I was suggesting to another Copley Medal winner recently that Fisher should be ranked up with Darwin, Newton, Einstein, maybe Watson and Crick for revolutionising, having a huge revolution on biology and statistical analysis and experimental design. But it seems his name's been rather forgotten about because of his name's been wiped actually recently from various places because of his connections to ideas that are now seen as politically incorrect, which I don't really want to go into at all, but I don't think is relevant to this. I think people should be remembered for what their achievements are in, say, science. Scholars, they should be remembered for their achievements, not what their political views were or their social views were. He came from a different era, late 19th century, early 20th century, when attitudes were different. I think people just accept the fact the world was different 100 years ago. There were different attitudes, and it doesn't make someone bad, and it doesn't make all this rubbish. So one I want to concentrate on is the fact he got the Copley Medal in 1955. Which I think is the world's most prestigious prize. ANOVA means analysis of variance. So it's a technique, he actually invented that through analysing crops, various crop plants, found in quantitative genetics. So this created some maximum likelihood, and maximum likelihood is it's a technique I actually want to use for some of my own research soon. He made it modern, and inferential statistics and the properties of this, which I'm just giving you an overview because there's too much detail otherwise. Principles of experimental design. Randomization. What's that to do with? I think it's the idea of getting rid of well, when you do multiple experiments, you often get variation in data. Some of it's errors, some of it's randomness, and so you repeat something over and over again to try to average out, get rid of all the errors and variations and make it statistically valid. Randomization is connected to that. The null hypothesis, which many people will have heard of, he actually invented. So the null hypothesis, I think that, the null hypothesis would be that dark matter out in space is not a particle. We did experiments trying to come up, and that involves p-values, which I'm can't tell you lots about top of my head. I'm not so, I'd have to revise a lot of this stuff. Blocking, I believe that's to do with dividing data up into various blocks, each one having it where you take sets of data with certain properties and characteristics and you divide it up to make it easier to analyze. Something called orthogonality. It's when you have, I think, n and n minus 1 sets of data, and it's a way of comparing. So I think it's contrast constraints. This can be in terms of vectors and sets, and you can show whether they're uncorrelated or independently distributed. It's just trying to show you what he did. He invented multifactorial experiments. When you have, say, if you have an experiment with, say, temperature, concentration, say experimenting on, say, enzyme reactions. So you have enzyme temperatures changing all the time, concentration of the substrate, the light levels, the sort of make sure there's no contamination or anything, all these different things, so you can evaluate the possibility of interactions and relationships between independent variables. And this kind of builds on ANOVA. And then F-tests, which allows you to compare variances. So this is just giving an overview of what Fisher did. But he got the Raw Medal, got the Copley Medal. I think he was alive before the Fields Medal came into existence, otherwise he may have won that. But ANOVA is a very well-known technique. So yeah, this is a rough, very brief overview of what he did. But he's basically seen as the father of modern statistics. So when you hear about p-values in particle physics experiments and dark matter and dark energy, this comes from Fisher. The null hypothesis, which you often hear about, and you certainly hear about that when you're doing school biology, GCSE, Nat 5, high grade advanced sci, you get taught the null hypothesis. This comes from Fisher. Randomization is, I think it's just random, or it's to do with, I think it's what I mentioned before, it's related to statistical, so getting rid of errors and variation. Experiments, just repeatedly doing experiments over and over again. You might do an experiment 50 times, 100 times, 200 times, 300 times. You just repeatedly do experiments to try to get rid of errors and make sure that the values are representing reality. Yeah, so this is a rough overview of Ronald Fisher. He should be probably one of the all-time greats. I think he should be ranked up with Darwin, Newton, Einstein, Watson and Crick and Maxwell. But his name's been wiped from various places. So yeah, that's him. But he got the Copley Medal in 1955, which recognised all this. So this year's Copley Medal, which is on metamaterials, Matt. I've been told an example of that is you can make lenses that don't use glass where you have gratings, and they cause diffraction of lighting. Light diffraction. Or refraction, diffraction or refraction. So you have a grating to create, again, refraction and diffraction. So that's a metamaterial. So yeah, I've heard of that one.